Imagine staring into the night sky, thinking you've seen it all until something utterly incomprehensible streaks across the cosmos. That's exactly what happened in 2017 when astronomers spotted a strange, cigar-shaped object hurtling through our solar system at nearly 200,000 miles per hour. It wasn't a comet, it wasn't an asteroid, it was Oumuamua, the first known visitor from another star system. And as scientists scrambled to study it, they realized something even more startling. This interstellar traveler was accelerating on its own, defying every known law of celestial motion. The discovery sent shockwaves through the scientific community, leaving experts grasping for explanations. Was it a piece of alien technology, a fragment of a distant world? Or something even stranger? This is just one of those moments when space science leaves us utterly stunned, when the universe throws a curveball so wild, even the brightest minds are left speechless. And that's what we're diving into today. 25-time space scientists were completely shocked by the cosmos. These aren't just minor surprises, they're earth-shattering revelations that rewrote textbooks, upended theories, and sometimes even made researchers question everything they thought they knew. From bizarre signals echoing across the galaxy to planets that shouldn't exist, each of these discoveries pushes the boundaries of what we believe is possible. So buckle up, because we're about to embark on a journey through some of the most jaw-dropping moments in space exploration. Picture this: black holes that sing, stars that vanish without a trace, and entire galaxies spinning in ways that defy logic. These aren't science fiction, they're real, documented events that left scientists scrambling for answers. And by the time we're done, you'll see why the universe remains the greatest mystery of all, one that keeps surprising us, no matter how much we think we've figured out. Ready to have your mind blown? Let's begin. The universe has a way of humbling us, and no moment captures that better than the night of August 15, 1977. Ohio State University's Big Ear radio telescope was quietly sweeping the skies when it picked up something extraordinary. A burst of radio waves so powerful, so precise, it didn't match anything natural astronomers had ever heard. For 72 electrifying seconds, the signal blared from the constellation Sagittarius with an intensity that dwarfed background noise by 30 times. When researcher Jerry Amon reviewed the data printout days later, he circled the alphanumeric sequence and scrawled a single, stunned word in the margin: "Wow." That scribble would become legendary. The signal's frequency aligned perfectly with the hydrogen line, a bandwidth scientists had long theorized extraterrestrials might use to communicate. It wasn't static, it wasn't satellite interference, and then, just as abruptly as it began, it vanished. Decades of follow-up scans, including rigorous searches by the SETI Institute, found nothing. No repeat, no explanation. To this day, the WOW signal remains one of astronomy's greatest enigmas. Some argue it was a comet's glancing reflection, though none were recorded in that region. Others whisper about military experiments, yet no earthly technology matched its profile. And yes, a few still dare to wonder, was it them? Whatever the truth, that fleeting blip forced scientists to confront how little we truly understand about the cosmos. Because if it was a hello from the stars, why did the universe suddenly go silent? For decades, the Pioneer spacecraft were supposed to be textbook examples of perfect cosmic billiard balls, hurtling through the void with predictable, unflinching momentum. Launched in the early 1970s, Pioneer 10 and 11 had already made history by beaming back stunning images of Jupiter and Saturn before continuing their endless journeys beyond our solar system. But then, something bizarre happened. As they drifted farther into the darkness, mission controllers noticed the probes were slowing down just slightly more than physics said they should. At first, the discrepancy was tiny, an extra deceleration equivalent to just 1/10 billionth of Earth's gravity. But over years of tracking, that minuscule anomaly became impossible to ignore. By the late 1990s, it was clear something was tugging on the Pioneers and nobody could explain what. The numbers didn't add up. Newton's laws, Einstein's relativity, every known force, none accounted for this. Scientists scrambled, proposing wild theories, unseen dark matter, a flaw in our understanding of gravity, or was there some mysterious, invisible hand reaching out from the cosmos? The truth turned out to be far more mundane, yet brilliant in its simplicity. After decades of head-scratching, a team of researchers finally cracked the case in 2012. The culprit wasn't some cosmic enigma, it was the spacecraft themselves. The Pioneer's own electrical systems and plutonium power sources were emitting tiny amounts of heat, and that heat was radiating unevenly off the probe's surfaces. Like a car's exhaust pushing backward, this faint thermal glow created just enough recoil to slow the craft by the exact amount that had baffled scientists. The revelation was equal parts relief and humility. It showed how even the slightest overlooked detail, heat from a power source, could send physicists spiraling for 40 years. But it also proved something profound. The universe does obey the rules. We just have to look hard enough to see them. Sometimes the universe doesn't just surprise us, it downright taunts us. That's exactly what happened in 2015 when astronomers discovered KIC 8462852, better known as Tabby Star. Nestled in the constellation Cygnus, this seemingly ordinary star began behaving in ways that defied every rule in the cosmic playbook. Most stars flicker gently like candles in a breeze as planets pass in front of them, but Tabby's star didn't flicker, it plummeted. At one point, its light dropped by a staggering 22%, as if something monstrous had slid across its face. The Kepler Space Telescope caught this bizarre dance, and when astronomer Tabitha Boyajian and her team saw the data, their jaws hit the floor. Nothing in nature dims a star that dramatically. Not planets, not comets, not even rogue asteroids. The dips were erratic, uneven, and utterly unpredictable. One theory exploded into headlines. Could this be evidence of an alien megastructure? Specifically, a Dyson sphere, a hypothetical swarm of solar panels built by an advanced civilization to harvest a star's energy. The idea wasn't just science fiction anymore. For the first time, scientists had to seriously consider whether we were staring at the handiwork of beings far beyond our world. But the cosmos loves a good plot twist. Follow-up studies revealed clues that pointed away from aliens, though not toward anything ordinary. Infrared observations showed no excess heat, ruling out a solid megastructure. Instead, the star's dimming might be caused by colossal clouds of dust, possibly from shattered planets or swarms of comets. Yet even that explanation feels flimsy. The dust particles would need to be microscopic to block so much light without glowing in infrared, a property no known cosmic debris possesses. Tabby's star remains an enigma. It's dimmed and brightened unpredictably for years, sometimes vanishing by as much as 15% for days or weeks at a time. Every time scientists think they've cracked it, the star throws another curveball. Maybe it's surrounded by a bizarre, uneven ring system. Maybe it's swallowing its own planets in slow motion. Or maybe, just maybe, we're glimpsing something entirely new, a cosmic phenomenon we haven't even named yet. What makes Tabby's star so thrilling isn't just the mystery, it's the humility it forces upon us. For all our telescopes and supercomputers, the universe still holds puzzles that leave the brightest minds muttering, "We have no idea." And that's the beauty of it, because every time we think we've seen it all, the cosmos winks back and proves we're just getting started. Mars was supposed to be a dead world, cold, barren, and utterly inhospitable to life as we know it. That's why scientists nearly dropped their coffee cups in 2013 when NASA Curiosity rover beamed back data showing something impossible, methane. Not just trace amounts either, spikes of the gas flaring up 10 times above background levels before vanishing without a trace. Here's why that's earth-shattering. On Earth, 95% of methane comes from living organisms, cows, bacteria, decomposing plants. It's a byproduct of life, and while methane can form through non-biological processes like volcanic activity, Mars hasn't had active volcanoes for millions of years. So when Curiosity's instruments sniffed those sudden bursts, some reaching 7 parts per billion, it wasn't just puzzling, it was electrifying. Had we stumbled upon the first whiff of extraterrestrial biology? But the cosmos despises simple answers. In 2018, the European Space Agency's Trace gas orbiter swept the planet with far more sensitive equipment and found nothing. Not a single methane molecule in the atmosphere. The contradiction was jaw-dropping. How could two elite missions, both designed to detect this exact gas, produce such wildly different results? Some scientists argue the methane is real but fleeting, perhaps being rapidly destroyed by Martian soil chemistry or ultraviolet radiation. Others suggest Curiosity itself might be the source, with rover materials outgassing tiny amounts. But the wildest theory, that subsurface microbes alive right now are releasing methane in short-lived pulses, only for it to disperse before orbiters can spot it. What makes this mystery so tantalizing is the sheer impossibility of ignoring it. If the methane is geological, it hints at active processes deep beneath Mars' surface, rewriting our understanding of the planet's interior. If it's biological, well, we'd have to rethink humanity's place in the universe. For now, the data wars rage on, with every new rover and orbiter adding fresh twists. One thing's certain, Mars isn't nearly as dead as we thought, and that revelation alone is enough to keep scientists and dreamers wide awake at night. Back in 2017, astronomers got the cosmic equivalent of a drive by shooting something from another star system zipped through our solar system so fast, we barely had time to study it before it vanished forever. That object was Oumuamua, a name that fittingly means scout in Hawaiian, and from the moment it was spotted, it refused to behave like anything we'd ever seen. First, its shape. Instead of the usual lumpy asteroid or icy comet, this thing was shaped like a pancake, or maybe a cigar, depending on who you ask, tumbling end over end through space. Then came the real shocker. It was speeding up, not just coasting on gravity's pull, but actively accelerating, as if something invisible were pushing it. Harvard astrophysicist Avi Loeb dropped a bombshell theory. What if this wasn't just a weird rock? What if Oumuamua was artificial, a piece of alien technology, maybe a solar sail or a probe from another civilization? The idea wasn't entirely fringe. The object's unusual reflectivity, combined with that unexplained acceleration, matched properties you'd expect from a thin, light-driven structure. Loeb argued we'd caught a glimpse of something engineered, and the scientific world erupted. Critics fired back, calling it sensationalism. Mainstream astronomers proposed alternatives. Perhaps Oumuamua was a nitrogen iceberg, chipped off a Pluto-like exoplanet, vaporizing as it flew and giving it that mysterious boost. Others suggested it was a cosmic dust bunny, a loose agglomeration of particles behaving in ways we'd never modeled. The debate still simmers today because Oumuamua left us with more questions than answers. By the time we noticed it, the object was already racing away, too distant for follow-up observations. Was it a natural oddity, proving the universe is stranger than we imagined? Or something even more profound, a calling card from beings we've yet to meet? Either way, Oumuamua shattered one assumption forever. The cosmos isn't just full of rocks and ice. It's full of surprises, and the next interstellar visitor might upend everything all over again. In 2007, a team of astrophysicists sifting through old telescope data stumbled upon something that shouldn't exist, a cosmic burst of radio waves so powerful, it packed more energy than the sun emits in months, all crammed into 5 milliseconds. They called it a fast radio burst, or FRB, and at first scientists assumed it was a fluke, a glitch, a quirk, maybe a malfunctioning satellite. Then they found another. And another, within years, these mysterious blips were being detected across the universe, some from galaxies billions of light years away. But the real shock came in 2016 when one FRB did the unthinkable. It repeated. FRB 121102, as it's catalogued, shattered every assumption. Unlike the one-off bursts, this one fired off again and again, sometimes in chaotic clusters, sometimes with eerie regularity. Nothing in known astrophysics could explain a natural object capable of such precise, recurring detonations. Theories spiraled, colliding neutron stars, exploding black holes, or, as some dared to whisper, artificial signals. The speculation reached fever pitch until 2020, when astronomers finally caught a break. A magnetar, a highly magnetic spinning neutron star, in our own Milky Way erupted with an FRB-like burst. Finally, a smoking gun, but here's the twist. While magnetars might explain some FRBs, they can't explain all of them. Many bursts originate from regions devoid of magnetars. Others are too energetic, too frequent, or like FRB 121102, too stubbornly repetitive. Even stranger, some FRBs exhibit scattering, a telltale sign they've traveled through dense plasma, suggesting their sources might be nestled in extreme environments like supernova remnants or near supermassive black holes. What makes FRBs so thrilling isn't just their mystery, it's what they reveal about the universe's hidden chaos. These bursts might be cosmic lighthouses, their signals distorted by the vast webs of matter they pass through, offering astronomers a new way to map the invisible structure of the cosmos. Or they could be something far wilder, celestial catastrophes we haven't even dreamed of yet. Every time we think we've pinned them down, FRBs defy us again, proving that even the emptiest corners of space crackle with secrets waiting to be unraveled. For nearly a century, scientists have measured the universe's expansion using one golden rule, the Hubble constant. This number tells us how fast galaxies are flying apart, a cornerstone of cosmology set in stone by Edwin Hubble himself. But in 2019, something went catastrophically wrong. Two of science's most trusted methods for calculating this crucial value started giving wildly different answers, and the gap between them isn't just a rounding error. It's a full-blown crisis that's tearing cosmology apart at the seams. Here's the problem. One method uses the cosmic microwave background, the faint afterglow of the Big Bang, to extrapolate the expansion rate from the early universe. The other relies on standard candles like Cepheid variable stars and supernova, measuring distances to nearby galaxies directly. Both approaches are meticulous, peer-reviewed, and backed by mountains of data. But they disagree by roughly 9%. To put that in perspective, it's like two GPS systems giving you directions to the same restaurant. One says turn left in 300 feet, the other insists it's 500. One of them has to be wrong, except neither will admit defeat. This mismatch, now famously dubbed the Hubble Tension, has forced physicists to confront a terrifying possibility. Our entire understanding of cosmic expansion might be flawed. The leading suspect, dark energy, the mysterious force accelerating the universe's expansion. Current models assume it's constant, but what if it's changing over time? Or worse, what if dark energy isn't alone? Some theorists are now proposing radical fixes, like an undiscovered dark radiation flooding the early cosmos, or even a fifth fundamental force tweaking gravity's rules. The most unsettling part, this isn't just academic quibbling. If the tension holds, it could mean that 70% of the universe's energy budget, everything we've attributed to dark energy, is fundamentally misunderstood. We might be standing at the edge of a paradigm shift as profound as when Copernicus realized Earth wasn't the center of the solar system, and the clock is ticking. New telescopes like the James Webb Space Telescope are now scrutinizing these discrepancies with unprecedented precision. Every fresh observation either tightens the knot or offers a lifeline. Either way, one thing's certain: the universe isn't playing by the rules we wrote, and that realization that after centuries of discovery we might still be cosmic beginners is the most humbling shock of all. Venus has always been the solar system's enigma, a broiling, toxic hellscape shrouded in clouds of sulfuric acid. So when researchers announced in 2020 that they detected phosphine gas in its upper atmosphere, the scientific world collectively gasped. Here's why that matters. On Earth, phosphine is almost exclusively produced by life anaerobic bacteria thriving in places like swamps and animal guts. It's not something that forms easily through natural chemistry, especially not in Venus' oxygen-free, scorching environment. The discovery, made using the James Webb Maxwell Telescope in Hawaii and later backed by data from the Oumuamua array in Chile, suggested something staggering, possibly microbial life floating in Venus clouds. The implications were explosive. If confirmed, it would mean life isn't just an Earth phenomenon, it could exist right next door, in one of the most hostile places imaginable. But almost as quickly as the excitement erupted, the skeptics pounced. Independent teams reanalyzed the data, arguing the phosphine signal might just be noise or misidentified sulfur dioxide, a common Venusian gas. Others pointed out that volcanoes or lightning, though rare on Venus, might produce trace amounts of phosphine without any biology involved. The debate grew so heated that by 2021, the original team themselves walked back their confidence, admitting the signal might be fainter than they'd thought. Yet the mystery refuses to die. NASA and ESA are now racing to settle the question with dedicated missions. Veritas and Da Vinci Plus, set to launch in the late 2020s, will map Venus' surface and sample its atmosphere in unprecedented detail. Meanwhile, private initiatives like Rocket Lab's planned Venus probe aim to get there even sooner, possibly within the next few years. What makes this controversy so electrifying isn't just the life on Venus idea, it's the way it exposes how little we truly know about our closest planetary neighbor. For centuries, we've written off Venus as a lifeless furnace. Now we're forced to wonder, could Earth's twin, hidden beneath those acidic clouds, harbor secrets we never dared imagine? Whether the answer is yes or no, one thing's certain: Venus just got a lot more interesting. We've always assumed our place in the universe was utterly unremarkable, a principle so fundamental it's called the Copernican principle, named after the astronomer who proved Earth isn't the center of everything. But in 2013, scientists made a discovery that cracked that assumption wide open. Turns out we're not just floating in an average corner of space. We're sitting inside a cosmic emptiness so vast, so bizarre, it's rewriting the rules of cosmology. Meet the KBC void, a gaping bubble of nothingness stretching 2 billion light-years across, with our Milky Way stranded somewhere near its middle. This isn't just any void. Most cosmic voids are gaps between galaxy filaments, regions where matter thins out. Think of them like the empty spaces in a sponge. But the KBC void is different. It's 7 times larger than any void we've ever seen, a staggering abyss where galaxies are suspiciously few and far between. When astrophysicists Istvan Kovacs, Ryan Keenan, and Amy Barger first pieced together its scale using galaxy surveys and supernova data, the implications were staggering. If we're truly inside this void, it means the universe isn't as uniform as we thought. And worse, our measurements of cosmic expansion, the very foundation of dark energy research, might be catastrophically skewed. Here's why that's a problem. Dark energy, the mysterious force accelerating the universe's expansion, is calculated based on how fast distant galaxies are moving away from us. But if we're sitting in a void, those galaxies aren't just receding because of cosmic expansion, they're also being tugged outward by the void's lack of gravity. Inside this bubble, space isn't just expanding, it's stretching faster than it should be. That means we might be overestimating dark energy's strength, maybe by a lot. Some models suggest the discrepancy could be as high as 15%, enough to throw decades of cosmology into question. Critics argue the void's existence is still contested, After all, mapping something this enormous from the inside is like trying to outline a stadium while standing blindfolded at center field. But the evidence keeps mounting. In 2020, a study of galaxy motions found a peculiar flow pattern consistent with a local underdensity of matter. Another team noted that certain supernovae appeared dimmer than expected, as if space inside the void were stretching faster than outside. The KBC void forces us to confront an uncomfortable truth: we might not be typical observers. And if we're not, then everything we've deduced about the universe, from dark energy to its ultimate fate, might carry an invisible asterisk. It's a cosmic curveball no one saw coming, proving once again that the universe doesn't just defy expectations. It obliterates them. Scientists thought they had the universe's inventory all figured out until they ran the numbers and realized something was dreadfully wrong. Here's the problem. According to the Big Bang's leftover light, the cosmic microwave background, the universe should contain a specific amount of ordinary matter: protons, neutrons, electrons, the stuff that makes up stars, planets, and us. But when astronomers tallied up all the visible galaxies, gas clouds, and dust, they came up shockingly short. Nearly half of the universe's expected matter was missing. For decades, this embarrassing gap, dubbed the missing baryon problem, haunted cosmology. Where could billions of tons of atoms just vanish? The answer was hiding in plain sight, or rather, in the emptiness between galaxies. In 2017, two independent teams finally cracked the case using a clever trick. They turned the universe itself into a detective tool. Here's how it worked. When light from distant quasars' extremely bright galactic cores travels through space, it gets subtly absorbed by any matter in its path. By analyzing the fingerprints of this absorption across millions of light years, researchers spotted the culprit: vast, diffused tendrils of superheated gas weaving between galaxies like a spider's web. These filaments, part of the so-called cosmic web, are so thin and scorching millions of degrees hot they're invisible to traditional telescopes, but they're everywhere, stretching across the universe in an intricate network of plasma. Think of it like this: if galaxies are cities, we'd spent centuries counting every building and car but completely missed the highways connecting them. These intergalactic filaments, though nearly intangible, contain enough mass to solve the missing baryon problem in one swoop. The revelation was equal parts triumph and humility. For years, we'd overlooked the universe's most abundant structures simply because they didn't glow brightly enough. But there's a twist. This gas isn't just sitting quietly, it's moving. Some filaments are being siphoned into galaxies by gravity, fueling new star formation. Others are being blasted away by black hole eruptions, redistributing matter across cosmic scales. It's a dynamic, invisible dance that shapes how galaxies grow and evolve. And now that we know where to look, astronomers are racing to map this hidden scaffolding with cutting-edge tools like the James Webb Space Telescope and upcoming X-ray observatories. What makes this discovery so profound isn't just that we found the missing matter. It's how it forces us to rethink the universe's architecture. The cosmos isn't just clusters of stars floating in emptiness. It's a living, breathing web with threads of plasma so vast they could wrap around the observable universe 1,000 times. And the wildest part, we're only just beginning to trace its patterns. In the vast cosmic dance of galaxies, we expect them to follow certain rules: bright, star-filled behemoths like our Milky Way, swirling with billions of suns. But in 2016, astronomers peering through the Dragonfly telephoto array stumbled upon something that defied every expectation. Dragonfly 44, a galaxy so ghostly, so devoid of stars, it was practically invisible. And yet, this cosmic specter held a staggering secret. It weighed as much as the Milky Way. How? Because lurking within it was an unimaginable amount of dark matter, making up an astonishing 99.99% of its mass. Here's what makes Dragonfly 44 so mind-bending. Most galaxies, even dim ones, have some visible stars, but this one, a mere 1/100% of its mass comes from actual glowing matter. The rest is an unseen, mysterious force, a dark matter woven through it like an invisible skeleton. Picture a skyscraper built entirely of scaffolding with only a handful of bricks. That's Dragonfly 44, a cosmic illusion, a galaxy-sized husk where light barely exists. The discovery sent shockwaves through astrophysics because, according to our best models, this shouldn't be possible. Galaxies form when dark matter's gravitational pull gathers gas and dust, which then collapses into stars. But Dragonfly 44 somehow skipped that last step. It collected unfathomable amounts of dark matter, enough to rival our own galaxy, and then just stopped. No star-forming frenzy, no brilliant spiral arms. Just an eerie, dim expanse floating in the cosmic deep. So what went wrong, or perhaps more chillingly, did it go right? Some theorists suggest Dragonfly 44 might be a failed galaxy, a place where star formation was somehow stifled. Maybe its gas was stripped away by a violent encounter with another galaxy. Or maybe, just maybe, it's a pristine relic from the early universe, a rare snapshot of what galaxies looked like before stars ignited, a frozen moment in cosmic time. The real kicker, Dragonfly 44 isn't alone. Since its discovery, astronomers have spotted dozens more of these ultra-diffuse galaxies, each a shadowy enigma. They've even found some with no dark matter at all, flipping the script entirely. Together, these ghostly galaxies are forcing us to rewrite the rules of how galaxies are born, live, and die. Because if the universe can build something as bizarre as Dragonfly 44, what other cosmic surprises are lurking in the dark? Most planets are made of rock, gas, or ice, but in 2011, astronomers found one that glittered like a cosmic jewel. PSR J1719-1438b isn't just another exoplanet. It's likely the universe's most extravagant diamond, a crystallized remnant of a catastrophic stellar collision. The story starts with its parent star, a pulsar spinning hundreds of times per second, the dense, city-sized corpse of a supernova. These cosmic lighthouses emit beams of radiation so precise, their pulse timing can detect even the tiniest gravitational tugs. That's how researchers noticed something bizarre. Rhythmic anomalies in the pulsar's signal, betraying the presence of an orbiting companion, but this was no ordinary planet. Calculations revealed an object with Jupiter's mass crammed into a sphere just half its width, making it denser than any known planet in the galaxy. So what could possibly crush matter that tightly? The answer lies in its origins. Scientists believe this planet began as a white dwarf, a dying star's core, locked in a doomed dance with its pulsar partner. Over millennia, the pulsar's gravity siphoned away the white dwarf's outer layers, leaving only its carbon-rich core under unimaginable pressure. In those crushing conditions, carbon atoms realigned into a crystalline lattice, forming a planet-sized diamond. But here's the twist: this wasn't a gentle transformation. The sheer violence of the process would have unleashed titanic forces, stripping the white dwarf down to a grotesque stub. Today, the planet orbits so close to its pulsar that a year lasts just 2 hours. Extreme doesn't even begin to cover it. Surface temperatures likely exceed thousands of degrees, with gravity so intense it would flatten any earthly material into paste. Yet for all its hostility, PSR J1719-1438b offers a glimpse into the universe's alchemy. It proves that under the right conditions, even stars can be forged into something utterly alien, a glittering testament to the cosmos' ability to transform destruction into dazzling beauty. And somewhere out there, other diamond planets might be waiting, remnants of stellar cataclysms we've yet to discover. Black holes aren't supposed to break the rules, at least not like this. In 2019, astronomers in China pointed their telescopes toward a seemingly ordinary star in the constellation Gemini, only to uncover something that shouldn't exist, a monstrous black hole named LB1 lurking silently beside it. At 70 times the mass of our Sun, this behemoth defied every known model of stellar evolution. According to theory, black holes formed from collapsing stars shouldn't exceed 20 to 30 solar masses. Anything larger should tear itself apart before it can collapse. Yet there it was, LB1, looming like a cosmic error code written across the sky. The discovery sent shockwaves through astrophysics because it didn't just stretch the limits of what we thought possible, it snapped them entirely. Stars that massive should end their lives in violent pair instability supernova, explosions so powerful they leave nothing behind, not even a black hole. So how did LB1 cheat death? One possibility is as dramatic as the black hole itself. Maybe it wasn't born from a single star at all. Instead, LB1 could be the product of a forbidden union, two smaller black holes merging in secret, their combined mass creating this celestial outlaw. But here's where the plot thickens. Merging black holes usually announce themselves with gravitational waves, ripples in space-time detectable by observatories like LIGO. Yet LB1's host star showed no signs of such a cataclysmic event. No unusual motion, no chemical traces of a violent past. It's as if this black hole simply appeared, fully formed, like a ghost materializing in a locked room. The implications are staggering. If LB1 isn't a merger, then our understanding of how stars die and how black holes are born might be fundamentally flawed. Some theorists now suggest that ancient stars in the early universe could have collapsed directly into black holes without supernova, bypassing the mass limit entirely. Others wonder if LB1 swallowed enormous amounts of gas and dust over eons, bulking up like a cosmic glutton. Whatever the truth, LB1 forces us to confront an uncomfortable reality. The universe doesn't care about our models. It'll happily build monsters just to watch us scramble for explanations. And as telescopes peer deeper into the cosmos, who knows what other impossibilities are waiting to be found? Deep in the frozen expanse of Antarctica, buried beneath a mile of glacial ice, the Ice Cube Neutrino Observatory silently keeps watch for cosmic ghosts, elusive particles called neutrinos that stream through the universe, barely interacting with anything they touch. On September 22, 2017, one of these phantoms did something extraordinary. It stopped, hurtling through space at nearly the speed of light. This single high-energy neutrino, dubbed IceCube 170922A, slammed into the ice with such force that it sparked a cascade of blue light captured by IceCube's sensors. But the real shock came when astronomers traced its path backward. This wasn't just a random particle from the void. It was a cosmic bullet fired by a monster 4 billion light-years away, a supermassive black hole devouring stars known as a blazar. For the first time in history, scientists had pinpointed the origin of a high-energy neutrino to a specific source across the universe. This wasn't just luck, it was a revolution. Until then, neutrinos were infamous for being nearly impossible to track. They pass through planets like wind through a screen door, making them cosmic riddles. But this one carried a critical clue, an energy signature so extreme it could only have come from an environment of unimaginable violence. When IceCube's team shared their coordinates with telescopes worldwide, the Fermi Gamma Ray Space Telescope and others swiveled toward the blazar, TXS 0506 plus 056. What they found confirmed the neutrino's origin. The blazar was in the midst of a ferocious outburst, spewing jets of plasma and radiation straight at Earth. This marked the dawn of multi-messenger astronomy, a new era where scientists don't just see the universe but feel it through multiple cosmic signals. Neutrinos, gamma rays, and gravitational waves now work together like pieces of a puzzle, each revealing facets of events invisible to traditional telescopes. The implications are staggering. If a single ghost particle can lead us to a supermassive black hole's feeding frenzy, what else might these cosmic messengers reveal? Dark matter collisions, alien power sources, phenomena we haven't even named yet. the ice cube neutrino didn't just solve a mystery, it tore open a doorway. Suddenly, the universe isn't just something we observe. It's something we converse with, decoding its secrets through signals woven into the fabric of reality itself. And if this is what one neutrino can do, imagine what trillions more might tell us as we learn to listen. In 1981, astronomers mapping the cosmos stumbled upon something so unsettling, they initially assumed their instruments were broken, a vast, gaping nothingness stretching 330 million light-years across. They called it the Boötes Void, and to this day it remains one of the universe's most baffling enigmas. Imagine carving out a sphere of space so enormous it could swallow thousands of galaxies whole, then finding it almost entirely empty. That's the Boötes Void. While most voids are gaps between galaxy clusters, this one is different. It's not just sparse, it's a cosmic desert with only 60 or so galaxies scattered across its unimaginable expanse. To put that in perspective, a region that size should contain at least 2,000 galaxies. Instead, it's a hauntingly quiet pocket of near nothingness. So what could possibly leave such a gaping hole in the fabric of the universe? One theory is as mind-bending as the void itself. What if it's the imprint of a parallel universe? Some physicists speculate that the Boötes Void could be the scar of a collision between our universe and another bubble universe in the multiverse, a cosmic accident that siphoned matter away like water draining through a crack. It's a wild idea, but not entirely implausible. If other universes exist, their gravitational tug might leave behind voids like this one. Then there's the statistical fluke explanation. Maybe against all odds, matter just didn't clump here during the universe's formation. Think of it like rolling dice a trillion times and getting a single, improbable streak of all ones. The universe is vast enough that even the unlikeliest anomalies might crop up somewhere, but the odds of a void this large forming naturally are astronomically low. Some estimates put it at 1 in a million. The real mystery isn't just the void's existence, it's what lurks inside. Those 60-odd galaxies aren't randomly placed. They're clustered along a narrow, curved line, almost like survivors huddled on a life raft. Some researchers argue this suggests the void isn't entirely empty. Instead, it might be filled with dark matter, an invisible scaffold holding these galaxies in place. Others wonder if the void is expanding, its emptiness exerting a gravitational push that's herding galaxies into these strange formations. Every new observation deepens the intrigue. In 2021, astronomers discovered that some of the void's galaxies are younger than expected, as if star formation somehow got a late start here. That's bizarre because most galaxies in sparse regions should be older, their star-making fuel depleted eons ago. Could the void's unique environment be rewriting the rules of galaxy evolution? Whether the Boötes Void is a multiverse artifact, a cosmic roll of the dice, or something even stranger, it forces a humbling realization: the universe doesn't owe us symmetry. It can and does build towering structures of galaxies alongside caverns of near-nothingness, just to remind us how much we have yet to understand. And that's the true shock, not the void itself, but the questions it leaves hanging in the dark. Comets usually don't make headlines unless they're dazzling the night sky until 2021, when astronomers Pedro Bernardinelli and Gary Bernstein uncovered something that rewrote the rules entirely. Hidden in old telescope data from the Dark Energy Survey was a frozen behemoth, Comet Bernardinelli-Bernstein, an 85-mile-wide monster barreling toward us from the Oort cloud. To put that in perspective, this thing makes Hale-Bopp, the iconic comet of 1997, look like a pebble. Hale-Bopp's nucleus was a mere 37 miles across, already considered enormous. But Bernardinelli-Bernstein, it's nearly 3 times wider, an icy leviathan so massive, it blurs the line between comet and minor planet. What makes this discovery even more jaw-dropping is its origin. The Oumuamua cloud, a shell of icy debris encircling the solar system far beyond Pluto, is supposed to be home to small, primitive chunks of ice relics from the solar system's infancy. But nothing this colossal should exist there. Current theories suggest comets form closer to the Sun, where gravitational forces can pack material tightly enough to build such giants. So how did a comet the size of a small country end up in the frigid outskirts? One possibility is that Bernardinelli-Bernstein is an interstellar interloper captured by the Sun's gravity eons ago. Another, even wilder idea, it might be a surviving fragment of a shattered superplanet, a remnant from a violent collision that occurred billions of years ago. Then there's the matter of timing. In 2031, this behemoth will make its closest approach to the Sun, still safely beyond Saturn's orbit, but close enough for telescopes to scrutinize its surface like never before. Scientists are salivating at the chance because Bernardinelli-Bernstein is a pristine time capsule. Having spent most of its existence in the deep freeze of the Oumuamua cloud, its ice and dust have never been baked by solar heat. Studying it could reveal untouched chemistry from the solar system's birth, clues about how planets assembled from the cosmic rubble. But here's the kicker. Bernardinelli-Bernstein isn't just rewriting comet science, it's forcing us to rethink how the Oumuamua cloud itself formed. If objects this massive are lurking out there, our models of the early solar system might be missing a crucial chapter. Were there more planet-sized bodies ejected into the darkness? Could the Oumuamua cloud be littered with similar giants, waiting to be discovered? Every new observation of this megacomet peels back another layer of mystery, proving that even in our own cosmic backyard, the universe still has the power to astonish. In 2008, astronomers analyzing data from the Wilkinson microwave anisotropy probe stumbled upon something that shouldn't exist, an eerie cosmic current dragging entire galaxy clusters toward one unseen corner of the universe. They called it the dark flow, and its implications were staggering. Imagine tossing a handful of leaves into a still pond, only to watch them all drift in unison toward some invisible drain. That's precisely what's happening across hundreds of millions of light years, with massive galaxy clusters moving at nearly 1,000 kilometers per second toward the same mysterious point in space. What makes this discovery so unnerving is that, according to everything we know about cosmology, this motion shouldn't be possible. The universe's expansion is supposed to be uniform, with galaxies drifting apart like raisins in rising bread dough. Yet here we have gigantic swaths of matter, some weighing as much as 1,000 Milky Ways, all streaming against the cosmic tide like salmon swimming upstream. The lead researcher, Alexander Kashlinsky at NASA, described it as like seeing the wind in a universe where no wind should blow. So what's pulling them? One spine-chilling explanation suggests the gravitational tug might be coming from outside our universe. Beyond the observable cosmos, there could be another universe, or perhaps a dense, massive structure from the chaotic early moments of the Big Bang, exerting its influence across dimensions we can't see. It's like standing in a dark room and feeling a breeze from a doorway you didn't know existed. If true, this could be our first indirect evidence of the multiverse, a concept straight out of theoretical physics now knocking on reality's door. Skeptics, of course, have alternative explanations. Some argue the dark flow might be an artifact of incomplete data, a statistical anomaly amplified by the way we measure cosmic microwave background radiation. Others suggest it could be the remnant of a primordial imbalance, a lopsided distribution of matter left over from the universe's birth. Yet even after years of scrutiny, the signal persists. Later observations from the Planck satellite and X-ray surveys only deepened the mystery, confirming that the flow extends much farther than initially thought. The most unsettling part, if the dark flow is real, it means our universe isn't the isolated, self-contained bubble we imagined. Something vast and unseen, something beyond, is reaching in and rearranging the cosmic furniture. Whether it's a parallel reality or a flaw in our understanding of gravity, one thing's certain: the universe just got a lot stranger, and somewhere in that darkness the answers, or perhaps even bigger questions, are waiting. In 1973, astronomers pointed their telescopes toward the constellation Monoceros, expecting to see yet another ordinary nebula, a cloud of gas and dust glowing softly in the void. What they found instead was a cosmic riddle so precise, so geometrically perfect, it seemed almost artificial. This was the Red Rectangle Nebula, a structure so bizarre that its nickname doesn't even do it justice. At its heart lies HD 44179, a dying binary star system, but the real spectacle is the nebula itself, a near-perfect X-shape with ladder-like rungs of glowing material stretching outward like the ribs of a skeletal hourglass. What makes this formation even more baffling is how it defies the usual chaos of stellar death. Most planetary nebulae, the glowing shells ejected by dying stars, are messy, asymmetrical affairs shaped by random stellar winds or the tug of orbiting planets. But the Red Rectangle, its symmetry is so precise, it looks like it was drafted by a celestial architect. The leading theory suggests that twin stars at its core are locked in a gravitational dance, their opposing jets of ejected material carving out that striking X-shape. As one star sheds its outer layers, the other's gravity pulls the debris into two conical outflows, colliding and fanning outward like water from a spinning sprinkler. Then there's the color, a deep, unsettling crimson that earned the nebula its name. But the Red Rectangle's glow isn't just from heated gas. It emits something called extended red emission, a mysterious infrared luminescence that scientists still can't fully explain. Normally, this kind of light comes from complex organic molecules, like polycyclic aromatic hydrocarbons, essentially space-borne soot. Yet the intensity and distribution here don't match any known compounds. Some researchers speculate the nebula might be filled with entirely new forms of carbon-based molecules, forged in the extreme environment of the binary star's death throes. Perhaps the most haunting detail is the nebula's ephemeral nature. In a few thousand years, a blink in cosmic time, the Red Rectangle will dissipate, its delicate structure erased by the relentless expansion of space. For now, it stands as a fleeting masterpiece, a reminder that even in death, stars can create wonders that defy imagination. And somewhere in that crimson X lies a puzzle we've only begun to decode. The universe has its own version of a toxic relationship, and it's playing out in the constellation Sagittarius, roughly 6,500 light-years from Earth. Meet PSRB 1957+20, nicknamed the Black Widow pulsar, a celestial predator that's slowly devouring its stellar partner. Discovered in 1988, this pulsar spins at a dizzying 622 times per second, blasting its companion star with enough radiation to strip away its outer layers atom by atom. Imagine standing next to a lighthouse that's also a flamethrower, and you'll get the idea. This isn't just violent, it's methodical. The pulsar's intense beams of gamma rays and high-energy particles act like a cosmic blowtorch, heating one side of its companion star to nearly 12,000 degrees Celsius. The star's outer gases don't just evaporate, they're ripped away at over 1 million miles per hour, creating a visible wake of superheated plasma trailing behind the binary pair like the tail of a comet. Telescopes have even caught this eerie glow in action, a shimmering trail of destruction stretching across space. But here's the twist: the Black Widow isn't just killing its mate. It's recycling it. As the companion star loses mass, the pulsar's gravity siphons some of that material onto its own surface, temporarily spinning up its rotation. It's like a vampire stealing its victim's youth, growing stronger with every bite. Over millennia, this process could leave behind nothing but a shriveled stellar core, a ghost of what once was. What makes this system so fascinating isn't just the carnage, it's the implications. The Black Widow offers a rare peek into how pulsars can rejuvenate themselves by cannibalizing their neighbors. Some astronomers believe this might explain why certain pulsars spin so impossibly fast they've been stealing energy from their partners for eons. And as telescopes discover more of these cosmic widowmakers, they're realizing just how common and how brutal stellar survival tactics can be. So next time you gaze at the night sky, remember, some stars aren't just shining, they're feeding, and in the dark between the lights, the universe's most ruthless dramas are unfolding in silence. For decades, astronomers noticed something odd about our cosmic neighborhood. The entire Milky Way, along with hundreds of thousands of other galaxies, was moving at an inexplicable speed toward a single point in the sky, hidden behind the thick dust clouds of our own galaxy's center. This mysterious force, detected in the 1980s, became known as the Great Attractor, a gravitational anomaly so powerful it was dragging us toward it at over 600 kilometers per second. Picture floating down a river only to realize the current isn't just carrying you, it's pulling everything around you toward some unseen waterfall. The Great Attractor's invisibility made it all the more unsettling. Positioned in the direction of the constellation Centaurus, it was obscured by what astronomers call the zone of avoidance, a region of the sky where the Milky Way's own dust and stars block our view of the distant universe. At first, estimates suggested the Great Attractor had the mass of tens of thousands of Milky Ways, concentrated in a relatively small region of space. But how superclusters, the universe's largest structures, weren't supposed to be that dense? Was this some bizarre cosmic accident, or were we missing a fundamental piece of the puzzle? Then came a breakthrough in 2014 when a team of researchers mapped the motions of thousands of galaxies in unprecedented detail. Their discovery rewrote the story entirely. The Great Attractor wasn't the final destination, it was just a waypoint on a far grander journey. The real force pulling us in, the unfathomably vast Laniakea supercluster, a cosmic web of galaxies spanning 500 million light-years, with the Great Attractor sitting near its heart like a gravitational anchor. Laniakea, Hawaiian for immeasurable heaven, isn't just a collection of galaxies. It's a flowing river of matter with entire galaxy clusters drifting along filaments toward shared points of gravity. Within this structure, the Great Attractor acts like a dense knot in the web, a focal point where multiple streams of galaxies converge. But even it pales in comparison to the true heavyweight of our cosmic neighborhood, the Norma Cluster, a massive gathering of galaxies lurking near the Great Attractor, adding its own immense gravitational tug. What's truly humbling about this discovery is the scale of our blindness. For years, we couldn't see the Great Attractor clearly because our own galaxy was in the way. Now, with infrared and radio telescopes piercing through the dust, we've realized the universe's largest structures have been shaping our fate all along without us even knowing. And the strangest part, this isn't the end of the journey. Laniakea itself is being pulled toward an even greater anomaly, the Shapley supercluster, a behemoth 650 million light-years away. So the next time you look up at the night sky, remember, we're not just orbiting the Sun or even the Milky Way's core. We're passengers on a galaxy hurtling through a hidden architecture of gravity toward destinations we've only begun to map. And somewhere beyond the dust, the cosmos is pulling strings we're still learning to see. The cosmic microwave background, the faint glow left over from the Big Bang, was supposed to be the universe's baby picture, a near-perfect snapshot of its infancy. But in 2004, astronomers poring over data from NAS, a Wilkinson microwave anisotropy probe, found something that made no sense. A vast, eerie patch of cold in the Simbi, stretching over 1.8 billion light-years across. They called it the cold spot, and it wasn't just a little cooler than its surroundings. It was anomalously cold, as if someone had pressed an ice pack against the fabric of spacetime itself. At first, scientists assumed it was just a trick of the data, a statistical fluke. After all, the universe is a noisy place. But when more sensitive instruments like the Planck satellite confirmed it wasn't an error, the real head-scratching began. The leading theory: this might be the imprint of a collision between our universe and another bubble universe in the multiverse. Picture two soap bubbles brushing against each other. The energy of that contact could have drained heat from our cosmos, leaving behind this cosmic bruise. It's a wild idea, but not entirely implausible. If other universes exist beyond our own, their gravitational tug could distort our CMB in ways we're only beginning to recognize. Not everyone's convinced, of course. Skeptics argue the cold spot could just be a supervoid, an enormous region of space where matter is unusually sparse. In these voids, light loses energy as it crosses vast distances, an effect called the integrated Sachs-Wolf effect, which could mimic a temperature drop. But there's a catch: the cold spot is too cold even for that. Measurements show the matter deficit required to explain the temperature dip would need to be far larger than any known void, so large, in fact, that it would defy our understanding of cosmic structure formation. Adding fuel to the fire, some researchers have found strange galaxy distributions around the cold spot, with fewer clusters than expected. Others have proposed even more exotic explanations, like a cosmic texture, a hypothetical defect in spacetime structure left over from the universe's early moments. These textures, if they exist, could create localized distortions in the CMB, like wrinkles in a sheet. What makes the cold spot so thrilling isn't just the mystery, it's the stakes. If it is evidence of a multiverse, it would be the first tangible clue that our cosmos isn't alone. And if it's a supervoid, it's forcing us to rethink how matter clumps together on the grandest scales. Either way, this icy anomaly is a reminder that even the universe's oldest light still holds secrets we've yet to unravel. And until we crack this cosmic cold case, the cold spot will keep staring back at us, a silent, frozen question mark in the sky. Black holes aren't just cosmic vacuum cleaners. Sometimes they're celestial fugitives. In 2023, the Hubble Space Telescope caught one in the act of fleeing, leaving behind a stunning crime scene, a 200,000 light-year-long trail of newborn stars glowing like breadcrumbs across the void. This wasn't just any black hole. It was a supermassive beast weighing as much as 20 million suns, racing through space at 4 million miles per hour, fast enough to travel from Earth to the Moon in under 15 minutes. And the wildest part, it wasn't supposed to move like this. Supermassive black holes usually sit like anchors at the centers of galaxies, their gravity holding entire star systems in orbit. So how did this one break free? The leading theory reads like a cosmic thriller. Billions of years ago, two galaxies likely collided, their central black holes spiraling toward each other in a lethal dance. As they merged, the gravitational waves generated by their collision might have kicked the resulting black hole clear out of its galactic home, a cosmic slingshot so powerful it sent the monster careening into intergalactic space. But here's the twist: as the black hole plowed through clouds of gas, it didn't just swallow everything in its path. Instead, its immense gravity compressed the gas in front of it like a snowplow, triggering bursts of star formation in its wake. Hubble's images reveal this dazzling contrail, a river of young, blue stars stretching across the darkness, a stark contrast to the aging stars left behind in the galaxy it abandoned. It's as if the black hole, in its reckless escape, became an unlikely midwife to new stellar life. The discovery forces us to rethink how galaxies and their black holes evolve. If these gravitational titans can be ejected so violently, how many others are out there, drifting unseen between galaxies, and what happens to the galaxies they leave behind? Without their central black holes, these star systems might lack the gravitational engines needed to regulate star formation, potentially spiraling into chaos. For now, this runaway black hole remains a singular spectacle, a cosmic outlaw whose very existence challenges our understanding of galactic dynamics. But with telescopes like JWST now scanning the skies, astronomers are hunting for others' proof that the universe's most destructive forces can also, paradoxically, light the way for new beginnings. And somewhere in that star-studded wake, we might just find clues to the untold stories of galaxies torn apart and reborn. The universe has a flair for the dramatic, but even by cosmic standards, at 2022 TSD was something else. Nicknamed the Tasmanian Devil for its relentless, unpredictable outbursts, this explosion defied every rule in the stellar playbook. Most supernovas flare up once, a brilliant, catastrophic finale, then fade into oblivion. But this one, it kept coming back, erupting in at least 14 violent bursts over the course of 4 months, each blast unleashing more energy than our sun produces in years. Astronomers had never seen anything like it, a cosmic tantrum that left theorists scrambling for explanations. The first clue came from the light itself. When the Zwicky Transient Facility in California spotted the initial explosion in 2022, it seemed like a typical supernova, but then, just as it should have dimmed, it flared again. And again, each burst lasted mere minutes, yet packed the punch of a full-blown stellar detonation. Spectroscopic analysis revealed extreme velocities, debris hurtling outward at nearly 1/10 the speed of light, far faster than any ordinary supernova could produce. This wasn't just a dying star, it was a celestial engine gone haywire, revving up and shutting down like a malfunctioning cosmic jackhammer. So what could possibly power such bizarre behavior? 2 leading theories emerged, each wilder than the last. The first points to a magnetar, a highly magnetic neutron star born from the supernova's core collapse. Normally, these spinning corpses emit steady pulses of radiation, but if this one formed with an off-kilter magnetic field, it might have experienced episodic starquakes, cracking open its crust and releasing pent-up energy in violent spasms. Picture a pressure cooker with a faulty valve, exploding not just once but in a series of furious eruptions. The second theory is even more catastrophic, a black hole playing cosmic puppet master. Imagine a star straying too close to a dormant black hole, not close enough to be fully shredded, but enough to suffer repeated tidal assaults. As the black hole's gravity pulls the star's material into swirling arcs, some of it could crash back onto the star's surface, triggering recurring thermonuclear detonations. It's like tossing logs onto a fire, only in this case, the fire is a dying star, and the logs are chunks of its own flesh. But here's the twist, neither theory fully fits. Magnetar starquakes usually produce smooth declines in brightness, not sharp, repeated spikes. And tidal disruption events typically involve single, drawn-out explosions, not this staccato rhythm of violence. Some astronomers are now proposing a hybrid scenario, a magnetar and a black hole working in tandem, or perhaps an entirely new class of explosion we haven't named yet. The Tasmanian Devil's true nature remains a mystery, but its implications are staggering. If such explosions are common, we might have missed them for years, dismissing their flickers as instrument glitches. Worse, their sheer energy could rewrite our understanding of how stars die, or how black holes play with their food. One thing's certain, the universe has a new kind of monster, and it's just starting to roar. Most cosmic objects move with a certain gray star's drift, planets orbit, galaxies spin. Then there's PSRJ 0002 plus 6216, a pulsar that doesn't just move. It flees. Discovered in 2018, this neutron star is rocketing through space at 2.5 million miles per hour, fast enough to cross the entire United States in under 5 seconds. But the real showstopper, the colossal 13 light-year-long tail of particles and energy stretching behind it like a cosmic contrail, earning it the nickname the Cannonball. This isn't just a runaway star. It's a celestial crime scene. That glowing tail isn't just debris, it's forensic evidence, pointing straight back to the violent explosion that launched this pulsar into the void. Astronomers tracing its path found the smoking gun, a supernova remnant called CTB1, roughly 10,000 light-years away in the constellation Cassiopeia. Here's how the chaos likely unfolded. About 10,000 years ago, a massive star reached the end of its life, collapsing in a supernova so powerful, it didn't just blow off its outer layers, it catapulted its own core clear out of the blast zone. Think of a champagne cork popping, only instead of a cork, it's a city-sized ball of ultra-dense neutron star material, and instead of champagne, it's a shockwave capable of shredding solar systems. The force of the explosion was so lopsided, it gave the pulsar a gravitational kick that sent it careening across the galaxy like a bullet fired from a cosmic gun. But here's where the story gets even wilder. The cannonball isn't just moving fast, it's accelerating. The pulsar's rapid spin generates a magnetic field trillions of times stronger than Earth's, turning it into a natural particle accelerator. As it plows through interstellar gas, this magnetic field acts like a cosmic snowplow, sweeping up material and flinging it backward in that spectacular tail. The result, a wake of high-energy particles that glows in X-rays and radio waves, visible from over 50,000 light-years away. What makes this discovery so groundbreaking isn't just the speed, it's the trail itself. By studying the tail's curvature and composition, scientists have reconstructed the pulsar's escape route with unprecedented precision, like celestial detectives tracking a fugitive's path through the galaxy. And the implications are staggering. If a supernova can eject its core with this much force, how many other hyper-fast pulsars are out there, hurtling unseen through the darkness? Could some have even escaped our galaxy entirely? The Cannonball pulsar is more than a cosmic oddity. It's a living lesson in stellar violence. Every flicker of its tail, every twist in its trajectory, tells the story of a star that didn't just die, but exploded with enough fury to send its heart racing across the cosmos. And as it streaks toward the galactic abyss, it leaves behind a question. What other celestial runaways are we missing, and what secrets might they carry from the graveyards of dead stars? The James Webb Space Telescope was built to peer into the cosmic dawn, to capture the universe's first starlight flickering to life after the Big Bang. So when it started spotting fully formed, massive galaxies dating back just 300 million years after creation, the scientific world froze. These weren't the faint, infant galaxies theorists expected. They were cosmic titans, blazing with mature stars and intricate structures, as if they'd had billions of years to grow. Except the universe itself was barely out of diapers. One galaxy, Glass Z13, was particularly shocking. It appeared to weigh as much as our Milky Way, but existed when the cosmos was just 1% of its current age. It was like finding a skyscraper in the middle of the Stone Age, defying every model of how galaxies form. Cosmologists scrambled for answers, one possibility. Our understanding of the early universe's timeline is catastrophically wrong. Maybe the Big Bang didn't happen 13.8 billion years ago, or maybe some regions of space experienced time differently due to extreme gravitational warping. Others suggest these galaxies might be fueled by ultra-efficient star formation, cramming stellar birth into hyper-accelerated bursts. Then there's the most radical theory. What if these galaxies aren't young at all? Some physicists speculate they could be remnants of a previous universe recycled through a big bounce, a cyclical model where universes collapse and rebirth eternally, leaving behind cosmic ghosts. Skeptics, of course, have less apocalyptic explanations. Maybe dust is distorting the galaxy's light, making them seem older and farther away than they really are. Or perhaps supermassive black holes at their cores are masquerading as stars, fooling our instruments. But with each new Webb discovery, like the shockingly massive Sparkler galaxy, whose globular clusters resemble ancient relics in a supposedly newborn cosmos, the anomalies pile up. The implications are staggering. If galaxies can form this fast, it upends decades of dark matter theories which rely on slow, gradual growth. It also raises existential questions. Are we missing a fundamental law of physics? Could time itself flow differently in the early universe? Webb's findings don't just challenge cosmology. They force us to wonder whether the universe's infancy was stranger, wilder, and more mysterious than we ever dared imagine. And with every deep field image, the telescope isn't just rewriting history, it's revealing how much we don't know about the cosmos' first whispers of light. From interstellar oddballs to runaway black holes, cosmic voids to diamond planets, every jaw-dropping discovery we've explored proves one thing: the universe loves keeping us guessing. These 25 shocks didn't just rewrite textbooks, they shattered assumptions, humbled experts, and reminded us that space science's greatest breakthroughs often start with someone saying, "Wait, that's impossible." Think about it. When the wow signal crackled through the void, it forced us to listen harder. When comet Bernardinelli Bernstein barreled into view, it revealed giants lurking in our solar backyard. And when Webb spotted galaxies too mature to exist, it yanked the rug out from under cosmic history itself. Each mystery, whether solved or still debated, is a testament to human curiosity, proof that the more we explore, the more the cosmos reveals how little we truly know. So here's the real question: which discovery left you speechless? Was it the Black Widow pulsar turning its stellar partner into a cosmic buffet, the dark flow hinting at unseen universes tugging at ours? Or maybe Oumuamua, the interstellar visitor that still has scientists at each other's throats? Drop your favorite in the comments. We're all part of this wild journey of discovery. And if today's cosmic curveballs left you hungry for more, you're in luck. The universe never runs out of surprises. Hit subscribe because the next big shock could be just one telescope image away. Who knows, the next time we meet, we might be unraveling an even bigger mystery, one that makes today's wonders look like child's play. Until then, keep looking up. The cosmos is just getting started.